Alright, Math 111. Today we are going to go over rational expressions. Let me get my writing utensil ready. Alright, rational expressions are where you have a p of x over a q of x, where p of x and q of x are polynomials, and q of x is not equal to 0. It's very important that q of x doesn't equal 0 because we don't want to divide by 0 and we don't have that 0 in our denominator. Okay, we're going to look at simplifying rational expressions. In order to do that, we're going to have to factor both the numerator and the denominator completely. And then once we have those both factored, we can usually simplify by eliminating factors that are common to both the numerator and the denominator. Okay, so let's do an example. So example 1 says simplify the following expression: x squared plus 5x plus 4 over x squared plus 3x minus 4. Like I said, we need to factor the numerator and the denominator completely. We are going to start with the numerator. Okay. Now, we need to factor x squared plus 5x plus 4. Okay, I'm going to factor that into two terms. We don't have a number in front of our x squared, so we should easily be able to factor both terms into an x and an x here. And looking at our last term here, that 4, we need two things that multiply to 4 and add to 5. So two factors that multiply to 4 and add to 5. How about 4 and 1? Okay, if you have a different method of factoring, use whatever method of factoring you would like. I just kind of did a little guess and check method there. All right, well, you can also work backwards to make sure it works. X times x is x squared. X times 1 is 1x. 4 times x is 4x. 1x plus 4x is 5x. And then 4 times 1 is 4. Okay, so you can check yourself to make sure you factored correctly. Let's factor the denominator now. Same thing. There is a 1 out in front of the x, or not a number out in front of the x squared. So we should be able to factor these two terms into an x and an x. I need two terms that multiply to negative 4 and add to a positive 3. So I'm thinking, how about a positive 4 and a negative 1? Because x times x is x squared. X times negative 1 is negative 1x. 4 times x is 4x. So negative 1x plus 4x is 3x. So that takes care of that middle term. And then 4 times negative 1 is negative 4. All right, so now we have completely factored the numerator and the denominator. What we want to look at next is if the numerator and the denominator have any factors in common. Hopefully you can see here that the factor that they have in common is the x plus 4. Okay, so our next step is going to tell us that we need to simplify by eliminating factors that are common to both the numerator and the denominator. So we are going to eliminate the common factors. So I'm going to cancel those x plus 4s out. Okay, and that's going to leave us with x plus 1 over x minus 1. Now, I can't simplify this because I have a difference in sign here. These aren't the same factor. Okay, x plus 1 is a different factor than x minus 1. And I can't pull the negative 1 out and get an x plus 1, because if I pulled a negative 1 out, I'd have negative x plus 1, which isn't the same thing as x plus 1. Okay, so here I really and truly have it as simplified as it can possibly be. So we went from this complex expression of x squared plus 5x plus 4 over x squared plus 3x minus 4 and was able to simplify it down to a expression of x plus 1 over x minus 1. Okay, that's kind of the process we will use. Let's look at example 2 here. Example 2, I have an x minus 1 over a 1 minus x. Okay, now x minus 1 is pretty much as factored as it's going to get. There's not much we can do there. In the denominator, we have 1 minus x. What I'm going to do here is I'm going to pull out a negative 1 so that I can get this x to be positive. Okay, if I pull out a negative 1 here, I should be able to turn that x positive, and then this 1 here should turn negative. If you can kind of see what I'm doing here, because now I have an x minus 1 in the numerator and an x minus 1 in the denominator. And what that's going to allow me to do is that's going to allow me to cancel out the x minus 1 from the numerator and the denominator. And that's going to leave me with a 1 in the numerator and a negative 1 in the denominator. 1 divided by negative 1 is just negative 1. So this entire expression here just simplifies down to negative 1. All right, let's try b. b is 4 minus x over x squared plus 4x minus 32. Now, I'm going to kind of do the same thing here. For the numerator, I really kind of want that x to be positive, so I'm going to pull out a negative 1. And that's going to leave me with an x minus 4 in the numerator instead of a 4 minus x. Okay, the x turns positive, the 4 turns negative. I put the x first just so that the factors will look the same once I factor the denominator. So factoring the denominator is what we're doing next. We have an x squared plus 4x minus 32. And we need to factor that denominator. So it should be able to factor into, I need a factor that'll take negative 32, multiply to negative 32, and add to 4. Okay, it needs to multiply to negative 32 and add to 4. Well, what are some factors of negative 32? You got negative 32 and 1. You could do like a 2 and a 16. That doesn't give you a 4 though. How about an 8 and a 4? An 8 and a 4 could give you a 4, especially if you subtracted them. So here's what we'll do. We'll add 8. We'll subtract 4. Now, x times x is x squared. X times negative 4 is negative 4x. 8 times x is 8x. 8x minus 4x is 4x. And then 8 times negative 4 is negative 32. So that indeed is a correct factor when we go back and check it. So if you have a different method of factoring, as long as it gets you the correct answer, that is fine. Now, hopefully you can tell at this point, we have common factors. The numerator shares a common factor with the denominator. That x minus 4 is common in both, so we're able to make a cancellation there. All right. Once we make that cancellation, we're able to simplify down to negative 1 over x plus 8. And that is as simple as that term can go to. And that'll be our answer. All right, let's look at addition and subtraction of terms. Now, when we want to add and subtract different terms, what we need to do is we need to first factor the denominators on both of those terms completely, and then determine what we call a common denominator. And ideally, when you determine a common denominator, you want to try to use what we call the least common multiple, or the LCM. So the LCM stands for the least common multiple. Okay, so let's practice a couple times on finding this least common multiple. All right, so this example says, let's find the least common multiple of x to the third power, y to the fifth power, and x squared times y to the third power times z squared. Okay, now what we have to do here is we have to account essentially for the greatest part of everything, but we don't want to go over the greatest part of everything. So I'm going to look at these individual terms. Here I have an x to the third and an x squared. I have to keep the highest exponent here. So the least common multiple should look like x to the third. Now we need to look at the next term. Here we have a y to the fifth and a y to the third. We need to keep the highest exponent. So I should have a y to the fifth here. And now I don't have any more terms on the first one, but I have a z squared on the second one. Okay, so there's no z here, but there's a z squared here. I have to keep that z and the highest exponent on it, which is the 2. So the least common multiple of x to the third, y to the fifth, and x squared, y to the third, z squared is x to the third, y to the fifth, z squared, keeping the highest exponent on all of them. Okay, and we can get to that term from both of these terms. In order to get to that term from here, all we would have to do is multiply this first term times the z squared. To get to that term from here, we would have to multiply by an x, a y squared, and that's it. We have to multiply by an x and a y squared. Okay, so it is possible to get there, and that is the least common multiple of those terms. Let's try the next one. The least common multiple of x and x minus 7. Now, these are individual terms, there's just a single term in the first one, and then there's a term here that involves a subtraction. Now, the deal is least common multiple means we have to multiply. So that subtraction there, in order to get the least common multiple between these two factors, I can't just subtract 7 from the first one. What I actually have to look at is the multiplication of both of them. So technically, the least common multiple of those two terms is x times x minus 7. Okay. Because we're looking at multiplying, not subtracting and adding. So I can't just add or subtract a term to another term to get a multiple of it. Okay, I have to actually multiply by something. And unfortunately, in this case, the least common multiple is both of them directly multiplied. Now let's look at the third example. The least common multiple of x plus 1 and x plus 1 squared. Now, this is a term and this is a term, right? There is an addition here, but it's the same term. X plus 1 and x plus 1. The only difference is this one's squared. Now, the least common multiple of x plus 1 and x plus 1 squared is actually x plus 1 squared. It's not x plus 1 to the third, it's just x plus 1 squared. Because all I have to do to get this x plus 1 to look like x plus 1 squared is multiply it by a whole nother x plus 1. And that's why that's the least common multiple. Okay. Now, once we're able to determine what the common denominator is, which is preferably the LCM if we're able to find it, we're going to be able to find that LCM, combine to a single denominator, and adjust the numerators accordingly, and then simplify the result when possible. Sometimes you get a really nice simplification, sometimes you don't. Okay, let's look at this example. It says 7 over x minus 2 minus 3 over x squared plus 2. We want to factor the denominators completely to start with. Okay, now if we look at the first one has a very simple denominator. It's just x minus 2. There's nothing I can really factor there. That is itself factored as far as it can go. Now, on the other one here we have a 3 over x squared plus 2. Now we have to ask ourselves, can we factor x squared plus 2? Well, in order to factor x squared plus 2, what we would have to do is we would have to have like a square root or something there. So it's not possible to factor this one either. So unfortunately, this one is also as factored as it can be. You don't always get to factor. This is as simple as both of the factors will be. Now we have to determine a common denominator, which is preferably the LCM. Now when we look at this one, we have an x minus 2 and we have an x squared plus 2. They look a little similar, but it's kind of like that second example we did on the previous page here, where they kind of look similar, but they're not really similar. So we're just going to have to multiply the two of them. So our least common multiple here is actually truly just x minus 2 times x squared plus 2, unfortunately. Okay. Now, what we're going to want to do next is combine to a single denominator and adjust the numerators accordingly. And what that means is you want to start with the denominator that you had. But we want it to be a common denominator. So on this first term, in order for it to be a common denominator, I need to add an x squared plus 2 to multiply to that x minus 2. And what I do in the denominator, I'm also going to have to multiply in the numerator, because we're essentially going to keep it as a multiplying by one factor. Because x squared plus 2 over x plus squared plus 2 is technically, when it's simplified, just a one factor, right? Then we're going to go to the next term, the 3 over the x squared plus 2, right? We want it to be a common denominator, so we really want that x minus 2 in there as well. So we want to multiply that in as well. If we do it on the denominator, we also have to do it on the numerator, so that we're technically only multiplying by 1 and not really changing the overall equation. Okay. Now that they have the same denominator, we can technically combine the numerator. So the numerator here should combine to 7x squared plus 2 minus 3 times x squared minus 2, all over x minus 2 times x squared plus 2. Now, we have to simplify that numerator. Sometimes when you simplify that numerator, you get some cancellations that'll happen. In order to simplify that numerator, what I need to do is I need to distribute the 7 to the x squared and the 7 to the 2 and then the negative 3 to the x, and the negative 3 to the negative 2. So let's see if we can do that. So 7 times x squared is 7x squared. 7 times 2 is 14. Negative 3 times x is negative 3x. And negative 3 times negative 2 is positive 6. Okay. The denominator, we're going to leave it as it is. Okay. So just rewriting the denominator. Now we need to combine like terms. Now the only like terms that we have are 14 and 6. We can combine those. Okay, so we're going to get 7x squared minus 3x and then plus 20 in the numerator. Okay, and then we're going to have x minus 2 times x squared plus 2 in the denominator. And you can sit here if you would like to, and you could multiply 7 times 20, which would give you 140, and try to figure out how you can get factors of 140 that simplify down to a negative 3 when added or subtracted, to try to then factor your numerator to simplify if possible. But in this case, this is as simple as this one is going to go. Sometimes you can refactor, like I said, refactor your numerator and have some cancellations after you've simplified. In this case, this is pretty much as simple as it goes. Let's do another couple of them. Excuse me. Now, part A says 3 over x minus 5 over x plus 3. All right. What we need to do first is we need to find the least common multiple of the denominator so that we can have a common denominator. So we're really looking at the x and the x plus 3 as a whole here. The common denominator here should wind up being x times x plus 3. Okay. Now, in this first term, we had an x and we had a 3 in the numerator. Okay, so a 3 in the numerator, we had an x in the denominator. If I want to multiply by x plus 3 in the denominator, I also need to multiply by it in the numerator when I combine to make a common denominator. And this second term here had a minus 5 over x plus 3. Oops. A little rough handwriting there, guys. And then I need to multiply by the x2 to get a common denominator here, so I need to multiply it in the numerator as well. Okay. All right, now we need to simplify some. So I'm going to distribute the 3 here to the x and the 3 to the 3. So it looks like 3x plus 9 minus 5x all over x times x plus 3. Okay. Now 3x minus 5x is negative 2x. So I'm looking at negative 2x plus 9 over x times x plus 3. If I could simplify the numerator or factor something out of the numerator to try to force a cancellation, I would. But in this case, this is once again as simple as it can go. Okay, you aren't always able to cancel something nice and neat. Sometimes you're left with a solution that doesn't simplify any further after this point. So our final answer here is negative 2x plus 9 over x times x plus 3. Now let's try B. B is 5 over x plus 1 plus 3 over x plus 1 all squared. Okay. Now, the common denominator here is going to be x plus 1 squared, which means that technically this second term here already has the common denominator as the denominator, so I don't need to do anything to it. But I do need to adjust this first term, because originally this first term only had an x plus 1 as the denominator. Now it has an x plus 1 squared, which means we've technically multiplied this entire first term by a whole nother x plus 1. So we need to make sure that comes up in the numerator. Now, pretty simple and straightforward. Let's simplify and combine. Here we've got 5x plus 5, because I did the distribution here, plus 3, all over the common denominator of x plus 1 squared. Okay, now we've got 5x plus 8 all over x plus 1 squared. Once again, there's nothing I can really do to the numerator to cancel anything in the denominator out, so it's pretty much as simplified as it can be. And 5x plus 8 over x plus 1 squared is going to be our final answer. All right? And that completes our first lecture, our rational expressions lecture. If you have any questions, please let me know. At this time, you should be able to go in and complete your homework on my math lab through the Pearson site on your Blackboard. If you have any questions, like I said, reach out and let me know. If you have any issues with your homework, let me know. And I will be more than happy to help you in any way I can. Other than that, I'll see y'all next time. Don't hesitate to reach out with questions.